If you are new to our channel, subscribe, like, and don't forget to share. Gravitation. Suppose two objects having masses m1 and m2, they are present in free space, vacuum, in this universe, and distance between them is r. So they will attract each other, and that gravitational force of attraction, that is directly proportional to product of their masses and inversely proportional to the square of the distance between the two objects. Combinedly, if I want to write the equation, it will be F proportional to m1 m2 upon r square. Now when we remove the proportional sign, we write a constant here, capital G and minus sign. Now remember that minus sign is only the significant that it is attractive in nature. Okay, it shows gravitational force is attractive in nature. If suppose we write the magnitude, or somewhere if it is written like this, g m1 m2 upon r square, that is understood that this is attractive in nature. Okay, but you will find somewhere in the NCERT there is negative sign. Sometimes they are not using negative sign, so don't worry. But my personal advice is always use the negative sign, because in so many derivations we have to consider negative sign. So best thing is, if we consider negative sign from the beginning, there will not be any problem. Okay, is this clear to everyone? Right. Now this formula that we have written here, that is the scalar form. Okay, in vector form, if I want to write this vector form, simply if I want to write force on first object due to second one, okay, force on first object due to second one, we will write minus g m1 into m2 r1 vector minus r2 vector divided by modulus of r1 minus r2 cube. Let's say this is equation number 2. Now what about the direction? We have written the expression direction of force on first particle due to second. So come here on the figure, m1 is being attracted by m2. It means direction of force on first particle due to second one is from 1 to 2. Similarly, if I want to write the force on 2 due to first one, it will be minus g m1 into m2, then r2 vector minus r1 vector divided by modulus of r2 minus r1 vector cube. This is the force on second particle due to first one. If I talk about the direction, m2 will be attracted by m1. So force, direction of force, that will be from 2 to 1. Okay, and simply we can write here, it follows Newton's third law of motion. How come? See, can I write r2 minus r1 vector as minus of r1 minus r2 vector? Yes or no? Okay. Same way, modulus of r1 minus r2 will be equal to modulus of r2 minus r1, because it is the distance between 2 points. Let's say this is equation number 5. Now I am using equation 3, 4 and 5. 3, 4 and 5. So from third equation I am writing minus gm1 m2 as it is. Instead of r2 minus r1 vector, I am writing minus of r1 minus r2 vector upon. Now instead of R2 minus R1 cube, I am writing R1 minus R2 cube. Now simply you can see minus into minus will be plus. Then G M1 M2 into R1 vector minus R2 vector divided by modulus of R1 minus R2 cube. Now observe the equation number 2. If I put the negative sign to the left side, okay, the value of this part you can see from equation number 2. This is minus of f of 1 2. Yes or no? So this shows Newton's law of gravitation that follows third law of motion. F of 2 1 equals to minus of f of 1 2.